Okay, this is question 2 for discussion week 7 on the web in the discussion section, not the worksheet. Okay, so combining these like terms, we're just going to combine like terms to simplify the expression. So we look to see how the terms are alike, and you look at the variable. The variable dictates whether you can add the terms. All of these have an x attached, so you can combine all three terms. In this situation, you have a 3y, a 4x, a 2y, and a 12x. You can't combine anything with x and a y. You have to combine what is the same. So you can combine these two terms, and you can combine these two terms, but that's all you can do with this particular problem. And we're going to go through all these steps. This is sort of an overview. In this situation, you have several terms, but you once again can only combine the ones that are alike. These both have an x on them, so our x terms can be combined. These have a y on them, so our y terms can be combined. This has an x squared, and nothing has x squared. This is squared, but it doesn't have an x squared on the term, so these terms are not alike. Another example of like terms would be just numbers. If you have 3 plus 4, you can of course combine that. And that just goes back to math we've known for a long time. Anytime you have numbers, you can always combine those. So we're going to go back to the first steps over here. And how this works is distributive property. It's based on distributive property. The fast way that most people learned how to do this is all you do is add the coefficients. That's what these big numbers are in front of the variables. So I was searching for a different color. If you have a term in front of each variable, and that's what you're combining. When they say combine and not add, because not all functions are adding. We have add and subtract. So what we're doing is 12 plus 3 minus 6. So let's pull that out. That's basically what we're doing. 12 plus 3 minus 6, which is then 15 minus 6, which is 9. You combined the coefficients, but your x has not gone anywhere. So your answer then is 9x. Another way to think of it as it's like factoring out an x, 12 plus 3 minus 6. But when you factored out an x like that, you have to combine all this or add and subtract it so that you end up with just the number 9. Because once you add and then subtract the 6, you'll end up with the 9 times the x, which is still 9x. So combining like terms, mostly people just use the simple shortcut, add or combine the coefficients and then put the x. Or if you need to think of it as factoring out the like term, which is the x, if you're factoring that out, then doing what's in the parentheses, then you still get back a 9x. So in this situation, oftentimes I like to rearrange the problem to make it easier, especially if I have a lot of terms. So you would have the 12x, and what I think of is moving the entire plus 4x. So I say plus 4x. And then I think of this y term. I carry the whole plus 3 at y. If it were negative, I'd be carrying the minus sign. And I could use that whole plus 2y. Now I've just arranged it so I can look at it easier. I'm going to combine this, and then I'm going to combine that. And in this situation here, 12x plus 4x, you just add the coefficients. So that would be 16x and then add these coefficients. Keep the plus because the answer is plus 3 plus 2, which gives you a plus 5y. You can't do anything more with that. It's simplified as far as it can simplify. Once again, if you're more comfortable looking at it from this perspective of factoring out an x from the 12 plus 4, that's also going to give you a 16x, just backwards. Doesn't matter because multiplication is commutative. And then this combined would be to factoring out a y, and then you would have 3 plus 2, which would give you that 5y. And you don't forget that it's all added. So you can look at it, that's a plus sign. You can break it apart into distributive property. Most students, as you get used to this, just simply add the coefficients or combine the coefficients on the like variables. Okay, so for this problem, 2x squared has nothing to combine it with, so no matter what, at the end of my problem, I'm still going to have a 2x squared. Can't do anything more with it. The 3y and the 2y will be combined, so we're going to just combine those in this example. 3 plus 2 is 5, so that gives me, it's a plus and a plus, that gives me a plus 5y. And then I'm going to combine the 4x and the 5x. That's 4 plus 5 gives me a plus 9x. And then we still have this left over. And this term can be simplified also. And 3 squared then just becomes 9. So you've simplified it as much as possible. Okay. And this one is done shorthand, or you can think of all the steps broken out in either way. This way or this way. And in this case, you can do it this way or break it out in this way.